Okay, if you're watching this video, it means you haven't given up yet. Well, that's good, because you're in the hardest part of the chapter already. The hardest part of this chapter, latent heat part 2, are these problems that start out, and they pretty much ask you, find Q for this. By the way, this is a guaranteed test question right here. And it's not just for me, it's probably for anybody teaching this. How much energy does it take to take a piece of ice, turn it from like -10 degrees, and make it steam that's 120 degrees? Good grief. First of all, it's going to have to give you one thing. It's going to have to, I'm going to go 10 grams. It's got to give you this massive ice. And I did one identical to this in the last video, basically. And this is what I need you to do is this. If you want to turn ice to steam, you got to think about what's got to happen first. To get ice to steam, you got to melt the piece of ice first. Well, here's the thing. You cannot melt ice that's at -10. So the very first Q I write, and I like writing it this way, representative, and it makes it so much easier. I've got to get that piece of ice from -10. I've got to heat it to 0 degrees. So I got to get a piece of ice from -10. I got to heat it to 0 before I do anything. Now, once I get that piece of ice heated to 0, I can actually do a QLF. I can actually start melting. LF stands for that melting process. LV stands for a vaporization process. So what happens after you've melted, all this ice is melted? Well, it's going to be water. But the thing is, it's going to be water, but this water that you created. So let's draw a little puddle of water right here. This puddle of water you got is going to be ice cold. That puddle of water is going to be 0 degrees. So now I've got to do a Q. Before I can boil that water and turn it into steam, I got to take that water that's at 0 and I've got to heat it up to 100 degrees. Now, once I get to the water to 100, I can start boiling the water, which would be a QLV. And now I can start boiling it. Good grief, I've got 1, 2, 3, 4 Qs. Well, guess what? You get one more. The last video I stopped right there because all I said was boil the water, turn it into steam. A lot of times a problem will say, all right, now, thank you, make the steam get hotter. Because you see, when you make steam, the temperature of steam is only 100 degrees, which means now we've got to heat the steam. We've got to heat it up from 100 to 120 degrees. And there is the entire problem. This is our problem, and now what we've got to do is go through and finish it. Here's the equations. Every one of these temperature changes. Every one of these is an MC delta T question. So we've got 3 MC delta T's. 3 MC delta T's. And then we've got these two that are both MLs and MLs. So really our problem looks like this. There is what our problem looks like. 3 MC delta T's added in with 2 MLs. I usually don't write out all this stuff. I just go straight for the part where I plug in numbers. So let's see if we can get into this and start doing some numbers. So I had 10 grams of ice. All right, are you ready? So 10 grams of ice times C for ice is 0.5 times delta of T means final minus the temperature. 0 minus -10. So 0 minus -10 plus ML, which would be 10 times LF for water is 80, positive 80, because we're trying to melt, plus, keep going, MC delta T, 10. This is where people get confused. Where am I at? 0 to 100. Well, that's water between 0 and 100. C for water is 1. And so it's going to be final minus initial. 100 minus 0. Oh my goodness, I'm still not done. Plus, again, now for this QLV. So M, which is 10, times LV for water is 540 plus, I'm going to run out of room on my paper over here. I got one more MC delta T plus same 10 times. Now here's the thing. 100 to 120. That means I've already boiled the water, I've turned it into steam, and now I'm superheating the steam. Well, I'm pretty sure, I'm going to double check, but you see C for steam, just like C for ice and C for water are not the same. I think C for steam is 0.45. Let me double check. Oh my goodness, I'm wrong. It is 0.48. Pardon me. 0.48 times delta T means final minus initial. 120 minus 100 equals, and I add it all up, and there is my problem. Holy cow, how did I get all this onto paper? I'm actually not even going to finish this one. If you got this far, you are more than capable of plugging all this in your calculator and getting... Okay, you talked me into it. I'll plug it all in. It's only going to take a second. 10 times 0.5 times 10 again, because that becomes positive. Plus 10 times 80 is 800. Plus 10 times 1 times 100. Well, that's 1,000 plus 1,000. Plus 10 times 540. Well, that's 5,400. Plus, now this is the only one I need my calculator on a little bit. 10 times 0.48 times 120 minus 100. Well, I think I can handle that. That's 20. 7,346 as you tried to do this on your own. And that would be in calories. And all I've done, I've spent 6 minutes reworking a problem from the last video. Why? Because it's so important. Now for what and by the way, I don't consider this to be the hard problem. I will now do the hard problem. The hard problem is this. You know how you did those problems where somebody took a hot piece of metal and put it in the water? Well, now somebody's going to do the same question, except they're going to take steam, and they're going to take the steam and put it in the water. Oh, my goodness. You're going to have to get crazy with this one. So what somebody is doing here is this. You've got water. Oh, my goodness, they're making it even harder. They've got water inside of a piece of glass. Good grief. And now they're going to take a blob of steam. Here comes my steam. They're going to stick the steam into the water. Holy cow, how did this happen? Well, let's see what we got. It said that we've got 200 grams of water. And this is, by the way, what I consider to be the good question. 200 grams of water. You've got 100 grams of glass. It does not tell me how much steam I have. It's looking for this steam. But it does tell me, look at this, it tells me that the steam is 130 degrees, and it tells me that the water and the glass are both 20 degrees. You see, the water is 20 degrees, and the glass is going to be 20 degrees. They're both going to be the same temperature because they're touching each other. And what it wants you to do, it wants you to make a temperature final of 50 degrees. It wants you to heat this water up. I know what you're thinking. Couldn't we just quit at the last question? No, I'm sorry. We've got to go a little step farther. So this is going to be a sum of the Q's equals 0 question. But it's going to be so much harder than the ones we did in the past. It won't be horrible, but let's see what we can do. You already know enough to start. You know you're going to have a Q for water. So we're going to have a Q for water. And let's do something. We're going to try and heat that water from 20 to 50. So I'm going to write Q for water 20 to 50. Because I'm going to try and heat that water from 20 to 50. Plus, I'm going to have a Q for glass. Because I'm going to try and take this glass and I'm going to heat the glass from 20 to 50. All right, well, that's not too bad so far. Plus, now this is the part where it gets good. Somebody's putting steam into this problem. The thing is, the steam's at 130. Q for steam what's going to happen to that steam? Before the steam can turn, the steam's going to turn into water. You're going to cool the steam off. Before steam can turn into water, the temperature has got to change. The temperature's got to drop from 130 to 100, and that's what blows people's minds. Is what? The temperature's got to drop from 130 to 100. Now, we ain't done yet. Now the steam, once you get the steam down to 100, the steam can actually change temperature again. Or not change temperature. Once it's actually down to 100, we can actually have, notice this, I'm going to write negative LV. The steam is going to lose energy and turn into water. Oh my goodness, it's getting crazy. Plus Q for the steam. And now this steam, the steam will be 100 degrees, is going to cool off to 50. And the physics is done with this problem. Turn it sideways so you can see it all in its majesty. Tilt your head. It's not that bad. Okay, so this is probably looking pretty rough. But anyway, there's where we've got right here. And I'm actually going to do another video and get us back into that. So anyway, pause here. Watch part 3.